It's hard though, right? But it's the same rules. It's the same rules, only with the notation. So just something we have to get used to. You know what I'm saying? So this one should be 6. That was B. Good. You should be like, woo. Try C. Do you know what I'm saying? Be positive with the team. The team needs your help. It is chain rule. Well, what's the chain rule when it's written like this? This is where it's confusing.
You do outside and inside.
Yeah. So what would that look like?
It's f prime of g of x times g prime of x.
That's exactly what it is. F of g of x. The derivative of this is derivative of the outside thing, leave what's inside alone, times the derivative of what's inside. Now what you need to do, though, is the x still goes into the g here, and you get a value. And then you f prime that value for this part. You know what I'm saying? Times the derivative of g. So there's a little, like, you know, the numbers traveling around. For example, g, what is this? Where, this is d. So d, where is this at? X equals what?
0, it's at 1.
At x equals 0. G of 0 is 1. Thank goodness, because this is all I have. So that's 1. F prime of 1. Does that make sense?
Yeah.
And then you can kind of play the game. Times g prime of 0 is 1/3. And then f prime of 1 is 5. So this is 5/3. Okay? You know, leave it off here then. Don't worry about g, because this is what I wanted to get into. It's when you do chain rule, it's kind of like, when do you stop going inside? Did anyone have issues with that? You know, it's times the derivative of what's inside. Did you do that? Did you like a lot? Because that's the hard part. It's like you start doing these things, and it's like you keep on going in and in and in, and it's like, well, when do you stop? Especially with like a sign, or like, what is inside? Did you have trouble with that on this homework?
Which one? G?
Just in general, like when you do chain rule, it's like, okay, the outside times the derivative of what's inside. Times the derivative of what's inside. Well, when do you stop going inside?
I have a question.
Yeah. Is 1, no, this is f prime, negative 1/3, sorry. Negative 1/9?
Yeah.
Negative 1/3. Is that what you guys got?
That's what I got.
F prime of 1. Negative 1/3 times g prime of 1 is, no, g prime is 0. There we go. Okay, cool. Alright, but here's what I want to talk about, because this ties into the next section. Like, when do we stop doing chain rule? Like, going back to what we were doing before, you got y equals x squared plus 5 cubed. If we wanted to break that up, like we can't take the derivative of this, you know, there's no rule for it. So what we did was we said, you know, u equals x squared plus 5. So y equals u cubed. Yes? And then what we did here is we dx both sides. We took the derivative in terms of x for both sides of this equation. We took the derivative of both sides in terms of x. So on this side we got du dx. Does that make sense, you guys? Equals d dx of x squared is 2x. d dx of 5 is 0. So we got du dx equals 2x. Yes? Then we come over here and we du both sides. d, du, d, du. So we get dy du equals, okay, we're doing d du of u cubed. And again, we know that rule because we spent so much time in chapter 2 doing these rules. We did them the long way. So to know that this derivative in terms of u is 3u squared. Does that make sense? And then we put them together. We said dy over dx is equal to dy du times du dx. Because like these two things will cancel out, leaving you with dy dx. And we said dy du is 3u squared and u was what was inside. 2 times du dx, which is 2x. Okay? Does that make sense, you guys? But why don't we go again? Why isn't this also times the derivative of 2x? Yeah, but like, remember, sometimes we do and sometimes we don't. Here's where it comes an issue. You know what I'm saying? And people are going to have issues with this. But it all breaks down to this. Like, if you can take the derivative of this, you know, this piece is done. If you can take the derivative of this piece is done. You know what I'm saying? But people are going to have some issues when you're doing chain rule. You're going to want to keep on going. You're going to always have a 2 to, there's going to be something extra. And I don't know, maybe this will help. Maybe it won't. If you keep on going in general, you can kind of treat every problem like a chain rule. If this was y equals 5x plus 1. Here's my my function or equation, y equals 5x plus 1. I want to d dx both sides. d dx. d dx. Okay? The left would equal dy dx. This is equal to, so the derivative of this, the 5x function, is 5, right? The derivative of this is 0. What you could do is times the derivative of what's inside. D dx of x. So yeah, what is that? You know what I'm saying? What is dx over dx? If it was a value, what would that be?
1.
Yeah, you know what I'm saying? So it does, like, in some cases, okay, if you keep on going, even though this doesn't make any sense, you know what I'm saying? We know what the derivative in terms of x is 5x. But if you chain ruled it or something, or if this was like, you know, x squared, it'd be 2x times the derivative of x, which is 1. Does that make sense, you guys? Like in this case, y equals x squared. If you d dx both sides, d dx, oh, chain rule, I don't know what's inside. I'm not sure what's in there. Let's find out. dy dx equals, bring the 2 down, x raised to the 1, times the derivative of what's inside, which is 1. Does that make sense, you guys? So are we good with that? But why I bring it up now is because what we're going to do in the next section is this. How the heck do we do that? Square root. Okay, you can square root it. You can do that, but then don't forget you'd have plus or minus, so that you'd have 2 equations to deal with. That's second derivative. You know what I'm saying? So now you're looking at what second derivative stuff. But what would I do here? Well, check this out. If you did d dx to both sides, d dx, this is what the notes are going to be on. You d dx both sides. Well, you start taking a derivative here. Again, knock, knock, knock. Who's home? I don't know. I have to do the 2 first. It doesn't know what to do yet. Do you know what I'm saying? So what's going to happen here? 2 comes down. 2 comes down. The y stays the same, raised to the 1, times the derivative, d dx, of what's inside. Equals, the derivative of this is 5, the derivative of this is 0.
Oh, and then you're going to do 5, yeah.
Well, what is dy dx? And that's just raised to the 1. No, what is dy dx in general? dy dx is your derivative. So if you wanted to know what dy dx is, or the derivative of this function is, you can still solve for it. In this case, you can just divide by 2y now.
Why wouldn't you just root?
You can, in this case, but you would have 2 equations to deal with. What it is, you would have the square root this. This is a sideways parabola. But you can do it together. And then it's y square root. Okay, well, what happens when you have this? I don't know. You know what I'm saying? The square root kind of runs out pretty quick. But check this out. What I want to show you is